Okay, so in this video I'm just going to have a look at variance and standard deviation. So I'm going to have a look at these two sets of data here. This one here is 1, 3, 8, 17 and 21, and this one here is 8, 8, 9, 11, 14. So what I've done here is I've just plotted these two sets of data on this graph here. So we have two scatter plots here of the data. Now if we were to take the mean of this set of data and the mean of this set of data, let's just work that out first. So let's just take the first one. We're just going to take 1 plus 3 plus 8 plus 17 plus 21, and we're going to divide by 1, 2, 3, 4, 5. This will give us our population mean, if you like. So when you do that, you'll find that you'll get, let's see, 3 and 1 is 4, 12, 29, 50 over 5, so that's just going to be 10. Okay, so we have a mean here of 10. So this is our mean along here, if you like. Okay, so this is our mean. Now let's do this one over here. Another set of data, so we just simply add them up. So we're going to do, let's see, 8 plus 9 plus 11 plus 14. We're going to divide again by 5, and this will give us our population mean. And here we'll get, let's see, 24, 25, 25, 50. So again, it's 50 over 5, which is 10. So we get the same mean here. So in this case, this is going to be our mean here. Now when you look at these two sets of data here, you can see that they both have the same mean, but this set of data here seems to be a lot more spread out than this one here. So how do we actually measure that? The way we're going to measure that is using variance and finally actually standard deviation. So well, actually one way you can measure this before we even do that is just simply the range. So we can measure the range of this set of data here, which is just simply 21 minus 1, the largest number minus the smallest, and we can see that's going to be 20. And the range over here is just simply going to be 14 minus 8, so that will just give us 6. So we can see we got a much bigger range here on this side than this side here. Now you can do interquartile range as well, which I've done in a previous video as well, but another way of measuring spread is, as I say, using variance or standard deviation. So basically what we're going to do here is, let's say if we take this case here, what we're going to do is just take the difference between each point and the mean here. So we're going to take, if you like, that distance there, that distance there, that distance there, this distance and this distance here. We're going to square it, square each one, add them up and divide by the number of distances, which is 5. So that will give us that's our definition of variance, if you like. We're going to do the same on this side. So we're going to find that distance there, that distance there, that distance, and that distance there. The distance that each point is from the mean. Square each one, add them up, and again divide by 5. That'll give us our variance. So let's just do that. Now I'm just going to take, just to remind me here, I'm just going to take this set of data here. I'll just copy that and bring it down a bit. So we'll come down here. Okay, so this is my first set of data here. The other one is, I'll put that in green, I can actually remember that one, I think. So that's going to be 8, 8, 9, 11 and 14. Okay, so let's look at working out the variance of each of these. So if we take this one here first, the variance is just defined really as the this symbol here squared, and this symbol here is called sigma, which is actually the standard deviation. So we're squaring the standard deviation, if you like. So this is our symbol for variance here. Now let's just work it out on the left hand side first. I'll come down here, I'll need a little bit of room. So what we've got to do is take each one of these points here and see how far it is from the mean first. So if we take 1, we're going to go 1 minus, our mean was 10, so we want to square it. The reason we're squaring it here is because if you do 1 minus 10 here, if you subtract 10 from 1 you get minus 9. We get a negative number, so when we square it, that'll just make that number positive. Now we're going to do the next one, which is 3 minus 10. I'm going to square that. Then we're going to do 8 minus 10, square that. Then 17 minus 10, square that. And then finally 21 minus 10, I'm going to square that. So when we do all of this, we're going to divide that by 5. We have 5 data points here. And when you do that, you get, rounded to one decimal place anyway, 60.8. Okay, so let's do the same on this side here. And see what kind of variance we get. Now I'm going to need to move down here. So let's say we have 8 minus 10, which we're going to square. We've got another 8 minus 10, which we're going to square. We've got 9 minus 10. We've got 11 minus 10. And finally we have 14 minus 10, which we're going to square. I'm going to divide all of this by 5. And when you do that, you get 5.2. So we have our two variances here, and you can see on this side here we have a much bigger variance than on the right hand side, which is what we would expect. There's a bigger variation in the distances between each point and the mean. Now the problem with these, they're kind of arbitrary numbers, if you like. They don't really relate to this to these numbers directly. So what you would normally do here is just simply square root each one. And when you square root each one, you get sigma here, which is called the standard deviation. So if we look at this side here, if we take sigma, this is our variance, and we're going to square root that. So we're going to square root our variance. So we're just going to square root 60.8, and that will give us approximately, just to one decimal place, 7.8, which makes a little bit more sense, and I'll just come back to that in a minute, to this data here. So let's have a look at the right hand side here. We have the square root of, again, the square root of our variance here, which is just going to be sigma, and that's going to be the square root of 5.2, which is 2.3. So our variance was 5.2 and our standard deviation here is 2.3. Our standard deviation on this side is 7.8. And if you look at the data here, if you take 10 here, for example, 10 here was our mean here was 10, and our mean on this side here was 10. So if you think about it here, our standard deviation is 2.3. It's like our average deviation from our mean is 2.3. And you can see here that 8 is 2 from 10, 14 is 4 from 10. So you can imagine our average deviation, if you like, is 2.3 from 10. Here we have a standard deviation of 7.8. Now here our lowest point here is 1, which is 9 units from 10. Here's 21, which is 11 units from 10. On the other side we have 7 units from 10, we have 2 units from 10, and we have 7 units from 10. So we can kind of imagine here that 7.8 would be our, if you like, our average deviation from our mean here, the mean of our distribution here. So this kind of makes a little bit more sense than our variation here, our variance rather, if you like. Okay, so that's it for standard deviation and variance.